All right, let's dive in. If you've ever built a really cool Flask app only to watch all your hard-earned data just vanish on a restart, then this explainer is absolutely for you. We're going to tackle one of the biggest hurdles for any Flask developer. How do you get your application to actually remember things?
So here's the core of the problem, right? By default, your Flask application is stateless. Now, that means it's fantastic at handling requests and serving up pages, but it has zero built-in memory. Any information you create, like a new user, a shopping cart, a blog post, it all just disappears the second that server stops. It's like it has amnesia.
You can see it right here. Without a database, a Flask app is a forgetful genius. You add your data, it works perfectly, but then a quick restart and poof, it's all gone. But when we introduce a database, our app suddenly gets a persistent memory. Data is saved, it survives restarts, and your application can actually grow and remember things over time. This is the huge difference between a stateless and a stateful app.
Okay, so how do we give our app this memory? I mean, we could write a ton of raw, complicated SQL code, but honestly, there's a much more elegant, a much more Pythonic way to do it. It's called an ORM, and you can think of it as a kind of magic translator that sits between our Python code and the database.
An ORM, or Object Relational Mapper, is this amazing library that lets you talk to and manage your database using just pure Python. It automatically translates, or maps, the Python objects we love to work with into the tables and rows that a relational database understands. Now, this isn't just simpler and faster for us developers, it's also way more secure because it helps prevent common attacks like SQL injection.
Now, in the Python world, the undisputed champion of ORMs is SQLAlchemy. It is an incredibly powerful and flexible library that's totally framework agnostic. That just means you can use it in any Python project, not just Flask. You should think of it as this industrial-strength engine that can connect to pretty much any database out there, whether it's PostgreSQL, MySQL, or even a simple SQLite file.
And to make our lives even easier, we use something called Flask SQLAlchemy. This is a specific Flask extension that basically takes that powerful SQLAlchemy engine and wraps it up for us, handling all the tricky setup and boilerplate code. It manages things like database connections and sessions automatically, so we can just focus on building our app, not on all the plumbing behind the scenes.
So let's be crystal clear on this. SQLAlchemy is the big, powerful, general-purpose engine. Flask SQLAlchemy is the specialized tool that seamlessly plugs that engine right into our Flask application. For pretty much any Flask project, Flask SQLAlchemy is what you want. It gives you all the power of the engine, but with none of the headaches of setting it all up manually. Okay, now that we have our tool, how do we tell the database what our data actually looks like? Well, with an ORM, it's as simple as writing a regular Python class. This class becomes the literal blueprint for our database table.
Now take a look at this. At first glance, it looks like a pretty normal Python class, right? But to SQLAlchemy, this is a complete blueprint for a user table inside our database. We just define the class user, make it inherit from db.model, and then we just list out the attributes we want to store: an ID, a username, and an email. It's really that intuitive.
And every single part of that class maps directly to a database concept. db.model is the base class that gives our simple class all these database superpowers. db.column obviously declares a column in the table, and then we specify the data types like db.integer or db.string, and we can add constraints like primary key equals true to make sure that the ID is a unique identifier for every single user.
So our app now has a blueprint for its memory. Awesome. How do we actually use it? Well, we're going to use 4 fundamental operations that form the backbone of pretty much any data-driven application out there. It's the CRUD toolkit.
CRUD. You'll hear this acronym everywhere. It stands for Create, Read, Update, and Delete. These are the 4 essential things you'll ever need to do. You'll create new records, you'll read existing ones, you'll update them with new info, and finally, you'll delete them when you don't need them anymore. Mastering these 4 operations is absolutely key.
To create a new user, first, we just create an instance of our user class, just like any other Python object. Then, we add this new object to something called the session. You can think of the session as a staging area, or a shopping cart, for all our database changes.
Finally, we call db.session.commit to take everything in that staging area and save it to the actual database.
Reading data is just as straightforward. If you want to get every single user in the table, you just call user.query.all. If you want to find a specific one, you can filter by any of their attributes, like their ID or username, and then just use .first to grab that single result. The code is just so clean and readable.
Okay, updating a record is almost laughably simple. This is where the ORM really shines. First, you find the user you want to modify. Then, you just change the attribute directly on the Python object itself. For instance, user.email equals new.email@example.com. That's it. You just commit the session, and SQLAlchemy is smart enough to figure out what changed and write just that update to the database.
And deleting is just as easy. After you fetch the object you want to get rid of, you just pass it to db.session.delete. This marks the object for deletion in our staging area. One final commit, and that record is gone from your database for good.
So, CRUD operations are the foundation, but let's be honest, real-world applications are always more complex. Data is usually connected, and your database structure is going to need to change over time. So let's level up with two critical concepts: relationships and migrations.
I mean, think about it. A blog isn't just a random list of users and a totally separate list of posts, right? No, a specific user writes many posts. A customer has many orders. This interconnectedness is everything, and our database has to be able to understand these kinds of relationships.
And what's great is that ORMs can model all kinds of connections. The most common one you'll see is one-to-many, like our one user having many posts. But you can also model many-to-one, one-to-one, and even really complex many-to-many relationships. For example, a single blog post could have multiple tags, and each of those tags could be applied to many different posts.
You might think this would be complicated to set up, but the implementation is surprisingly simple. In our user model, which is the one side of the relationship, we just add a db.relationship field. This creates a kind of magic attribute, like user.posts, that will automatically contain a list of that user's post objects. Then, over in the post model, the many side, we add a db.foreign-key to link it back to the user's ID. These two lines are all it takes.
All right, here's the next huge real-world problem. Your app is a success. People are using it. Now you want to add a new feature, maybe a profile_picture_URL column to your user table. If you just change your Python model and restart the app, you're either going to get a big error, or even worse, you might have to delete your whole database, losing all of your precious user data. There has to be a better way.
And of course there is. The solution is something called database migrations, and we handle it with a tool called Flask Migrate. The workflow is so simple. You run a init just one time to set things up. Then, anytime you change your models, you run migrate. This automatically looks at your changes and generates a script. Finally, you run upgrade to apply that script, which safely alters your database structure without losing a single row of data.
And with that, you now have the entire toolkit. You know how to connect Flask to a database, how to define your data with models, how to perform all the essential CRUD operations, and how to manage relationships and schema changes like a pro. You can now build truly robust, data-driven applications that remember things. So the only question left is, what are you going to build first?